To draw an isosceles triangle, you might be given different kinds of information. The simplest isosceles triangle to draw is that one where you've been given all the three sides. Let's keep our base to be 70 millimeters. Then we draw our construction line where we're going to put our base. Let's say our isosceles triangle is triangle BCD. So we have the side BC, which is 70 millimeters. As you can see in the question, we're going to be drawing an isosceles triangle whose equal sides have the length of 90 millimeters. So we're going to get 90 millimeters on our rule. We're going to stand at B and at C. I've started with C. Strike an arc just like we did earlier. And we have our isosceles triangle. So notice we just use those distances and then find point D. And now we can outline our triangle. Side BC, side BD, side CD. A very simple way to draw our isosceles triangle. Let's try a more interesting example. Let's construct an isosceles triangle with the base of length 40 millimeters and base angles equal to 60 degrees. So as you can see, I've picked my distance there, and I can draw my construction line there. So this is our base, EF. And now they've told us that the base angle is 60 degrees for each angle at E and F. And I'm sure you can remember what the base angle is, the terminology I talked of earlier. And I hope you can also remember how we construct the 60 degrees. Mostly for questions about triangles, when you see that that angle that they've given you is easy to construct, it's better that you just construct it rather than you getting your protractor and then measuring it. So that's a construction line. This other one too is a construction line. If you see, the lines that I am just from drawing meet at a point. That is point G. So our base is 40 millimeters. Our base angles are 60 degrees. Now, notice something here. I picked this example for a reason. If I try to measure my distance of the sides EG and FG, you find that these sides are actually equal to my base. That isn't a mistake. It's for a good reason. Side EF is equal to side EG, which is also equal to side FG. This is because our base angle is 60 degrees. So an equilateral triangle is kind of a special isosceles triangle whose base angles are 60 degrees. However, this isn't the case for any isosceles triangle. Like you saw the first one we drew, these base angles are going to be equal, but side BD is not equal to side BC. It is only when our base angles are 60 degrees when side EF or the base is going to be equal to EG and FG, which are the other sides of the triangle. We're going to do a more interesting type of isosceles triangle. This time, we've been given the base angle of 45 degrees and we've been given the altitude, which is 60 millimeters. We are asked to construct an isosceles triangle. The first thing we do is draw our altitude. I hope you remember what the altitude is. To do that, we're going to draw a baseline in construction, just a long one. We measure our altitude, which is 60 millimeters. Then we draw parallel lines with these 60 millimeters. We have a triangle and we are just from drawing parallel lines. Here, to understand the concept that is allowing us to draw this, we're going to look at some mathematics. Since we have two parallel lines that are making our altitude, we can apply mathematical concepts that are used when we're dealing with parallel lines. From mathematics, we know that the angle that will be at this point is going to be the same as the angle that is going to be at this point. These angles are referred to as alternate angles. In our example, we're looking at a triangle that is triangle HIJ. Now notice even the other side here has alternate angles. Therefore, for us to have an isosceles triangle, we're just going to construct the base angles at point J. After drawing them, you'll see that we'll have a triangle. Let's do that. Now, we need to select a particular point where J is going to be. Let's say we select a point here that is going to be our J. Then at point J, we construct a 45 degrees on our left and our right. So we select a radius that we're going to work with. In my working here, I'm going to use a lot of the method of bisection of an angle. This is because I know that 180 divided by 2, or simply half of 180, is 90. And then half of 90 is 45. So that is a very quick way of me getting my angle. Here I've changed my radius just to show you that the radius that you pick when bisecting does not need to be the same as this first radius here. And there we have our base angles. So now we can draw our triangle. This is H, and then this is I. This is how we can do that simple example question. I will quickly go through what we did. We first drew our altitude. After drawing our altitude, we selected the point J, and then we constructed a 45-degree angle on the left of J and on the right of J. So we stood here open to a radius and then made these points. We can say this is point 1 and point 2. Then we bisected this angle that we formed here by 1 and 2 to get this point here, which we can call 3. After we get point 3, we join point J and point 3. Then on our arc that was used to make 1 and 2, we have them intersecting at a point 4. Then after that, we stood at point 4, opened our compass to 1, then struck an arc, stood at point 1, struck an arc, and did the same for 4 and 2. After we did that, we had our 45 degrees. Then we drew a line from J that passed through our points that we can call 5 and 6. That cut our baseline here. And that's how we made this isosceles triangle. Now, this kind of isosceles triangle we drew is not just any kind of isosceles triangle. It's actually our 45 set square just drawn down to a smaller scale. Remember, we said this is 45 degrees and 45 degrees, right? Interesting, eh? Let's try an even more interesting isosceles triangle. In the third example here, we're going to be constructing an isosceles triangle with a given perimeter and altitude. The isosceles triangle we're drawing is KLM, and the altitude of this triangle is 60 millimeters, while its perimeter is 100 millimeters. To start with, we'll draw a line where our baseline is going to be located in construction. Then we get half of our perimeter, which is 50. We just divide 100 by 2. We mark on this line 2 points. We can call these points point 1 and point 2. We stand at point 2 and construct a 90-degree angle. This time I'm not going to use bisection. Obviously, you might be asking yourself, why not just get my t-square and my set square and just make a 90 like that? Well, the answer is simple. Triangles is a common place where you're tested on the knowledge that you know about how to construct angles. So our height is 60 millimeters. So now I'm marking it. I stand at point 2. And then I have a point. Since this is my altitude that I have just marked at point 2, I'm pretty sure this point here is going to be M. After that, I join point 1 and point M. And then I bisect the line 1M. To bisect, I stand at point 1 or M, open to a radius more than half. I've just realized if I pick this radius, the work won't be so clear. I'll have to make an arc on these lines that I drew. So remember, on the drawing instrument, it was important that you have a rubber, right? Yeah, so it would be helpful if you had one already. So I open to even a larger radius so that I can have my arc on this side. For bisecting a line, it doesn't matter if your arc is bigger than the line. It should just be more than the radius. I stand at M. You can see my arc at 1 there is not intersecting. Now I have some intersecting arcs. I have just bisected my line 1M. And now I have a new point here where this bisector meets our line that we drew for our baseline. This point here is going to be one of our vertices for our isosceles triangle. So I'm going to join this point and M. And now, if this is an isosceles triangle, then this point here I'm just from having can be named L. And then I pick the distance to L. and strike an arc with my compass standing at point 2. And aim. And now I have point K. And then I outlined KL. That's how we can draw our isosceles triangle given the altitude and the perimeter. A quick recap. First, we draw a construction line where our baseline is going to be. Then we get half our perimeter. We made these marks 1, 2. That's half our perimeter, 50 millimeters. Then at point 2 or even point 1, we make a 90-degree angle. After we make that 90-degree angle, in this case we selected point 2, what we're going to do is get our altitude and mark it on the line from point 2. Then we'll have a point M, which is the vertex at the top of our triangle. Then we join that point and 1. After joining those 2 points, we bisect the line 1M and then look for a point where this bisector meets with that construction line that we drew for the baseline. After we can see that point, we join that point and M, and we have one of the sides of our triangle. Then we look at point 2, get that distance 2 to that point of intersection which we named L, and then strike that distance on the other side. After that, we join that new point which we called K with our M, and then we have another side of the isosceles triangle. Finally, we outline our baseline, which is KL. With that said and done, now let's look at another way of constructing a triangle. The first thing we are going to do is draw a construction line where our baseline is going to be, and then we're going to mark our perimeter, which is 180. Basically, that's just 18 centimeters. I was almost accurate in my estimation of the line. Okay, so let's label this AB. Notice I've used just some small or lowercase letters. Then let's divide line AB into the sum of the numbers used in our ratio. So we have 1, 2, and 1. We add those numbers up, 1 plus 2 plus 1, which gives us 4. So we have to divide line AB into 4 parts. Notice we're not drawing a triangle ABC this time. We're drawing a triangle NOP, so we haven't yet started drawing our triangle. This is just some procedure that we need to follow to divide our line. We do what we learned in the basics. So we're going to extend construction line like that. This construction line, we're going to make 4 marks. We stand at A. We have our first marking, second, our third, and our fourth. You can label these 1, 2, 3, and 4. We join point 4 and B. And then what we need to do here is go back to our ratio. This is very, very important. We know that after we divide the line, usually we kind of transfer this line to 3, 2, and 1, or simply we're going to draw parallel lines to 4B at points 3, 2, and 1. It's usually a procedure that you do without even much thought. But this time when we're drawing a triangle, when we've been given the ratios of the sides and the perimeter, we need to be selective which points we're going to transfer this line to. Remember, our ratio of sides is 1 to 2. So when we get these 4 points and then we start sliding, there's an important concept that you need to realize what we're actually doing here. So I've placed my set squares correctly for me to be able to slide. Remember, our ratio is 1 to 2 to 1. So on these divisions, we have those ratios. So let's say this is part 1, then the other side is going to get 2 parts, this part and this part. Then the remaining side is going to get 3, 4. If the base is not specified, maybe like them telling us that the base has the ratio 2, you can order these ratios in any way, but the best way to do is order them in the number that in the way that they have been given. So notice our ratio is 1 to 2 to 1. So what we'll do is we'll go to point 1. The first ratio is one that will guide us on how to start. We go to point 1 and then draw a line that is parallel to 4B. Then we're going to count the number of times equal to the next ratio. Our next ratio is 2, so we count 2 steps forward. We go 1, 2, and then we draw a parallel line to 4B like that. And then we count the next ratio. The next ratio is 1, so 3, 4. You see how that simple procedure can easily make you remember the concept behind, and at the same time help you remember the method. This shows us that now this is going to be point N, this is going to be point O, and then now we just need to know how to get point P. Let's outline NO to make things look a bit more clear. Now, how are we going to get point P? Well, it's not very difficult actually. We stand at N and then open to the side opposite, which is B there, not this one here, B. We strike an arc and then we go to point O, we do the same and we strike an arc. I'm very lucky here, my point P is just at the border. This shouldn't be the case when you're drawing. Don't really enter into that border, but I'm lucky it's just before the border. Then I join N with that new point. Then O with that same new point. That point is P actually. So we join O and point P. And there we have our triangle. Notice because of the types of ratio that we were given, 1 to 2 to 1, we kind of have an isosceles triangle again. So we've looked at the isosceles triangle and many methods in which we can make an isosceles triangle. These methods that we've looked at are not only towards the isosceles triangle. They can be applied to any type of triangle depending on how the question is brought. For example, when we talk about ratios, if our ratio is, let's say, 1 to 1 to 1, it means our triangle that we're going to draw is going to be an equilateral triangle because all the sides have got the same ratio. However, we won't opt for using this method that I'm just explaining to draw our equilateral triangle because it will be kind of long unless we've been just fixed to draw that equilateral triangle using this method. In example 2, we looked at how we could construct an isosceles triangle given the base angles and the altitude. That angle is not that method is not specific to only the isosceles triangle. So when we look at the next type of triangle, we're also going to pass through that method quickly and then see how it can be used to make other triangles. That's it for isosceles triangles.